Hello there and welcome to Lower 6 Maths A-Level Practice Paper A. And here we're working on question 1, 4 marks, an inequalities question. Prove that for all values x, this expression holds. So that means that no matter what number I put in for x, so say I put in the number 2, the left-hand side is always going to come out on top or larger than the right-hand side. So if I work out what I've got here, I'm going to have 2 squared is 4, plus 12 is 16, add 18 is 34, and that's going to be greater than 1. This is going to happen for all the numbers that I can try and put in here, but to save time from putting in all the numbers, I'm going to try and prove this algebraically. So what's easier than proving that some expression is greater than some other expression is to prove that something's greater than 0. So what I'm going to do first is move everything from the right onto the left. So x squared, and I'm going to add on half an x, so that will give me a 13 over 2, or 6.5. And then I'm going to take away 2 from here as well, so I'll go add 16. And what I need to do is prove now that this is bigger than 0, which is much easier. And a really good way of proving that something is positive is to complete the square, because completing the square will give you a squared expression and hopefully add something positive. Squared expression means positive or 0, and add on something will hopefully give you something positive as well. So completing the square, let me remind you, we have a bracket with a squared function on it, and then we have x plus or minus something. In this case it's a plus, because half of this is going inside the bracket, 13 over 4. And then if we remember that x plus 13 over 4 squared looks like this, what we're going to get is we're going to have the x squared and the 13 over 2 from both of these expressions here, but we're also going to get an extra 13 over 4 squared that we didn't anticipate on. So we'll have to take that away. 169 over 16, and then plus in this 16 here that we haven't factored in yet. And what would be really good to do with this 16 is to write it also as a fraction over 16 so that it makes life easier for me. And this is going to be 256. Okay, so we're still proving that this is greater than 0. So we're going to have x plus 13 over 4 squared, and we'll simplify what we've got on the tail of this. So 256 take away 169. Let's get the calculator out. And we get here, add 87 over 16. And this is greater than 0. Okay, so what we now have to do here is we can see that this is greater than 0. Anything that's from this part of the expression here is always going to be positive because it's a squared part, and this part here will additionally increase that value as well. So what we need to write is a little sentence just to conclude this, as x plus 13 over 4 squared is greater than or equal to 0. Greater than or equal to 0, because if x was minus 13 over 4, this expression here would be 0 squared, which could equal 0. So we need an equal sign on there. As this expression is greater than or equal to 0 by the fact it is a squared value, the addition of 87 over 16 will keep this positive and non-zero. Okay, so you need that little expression there, and non-zero, as it can now no longer equal 0. So therefore, little triangle of dots there, x plus 13 over 4 squared add 87 over 16 squared will be greater than 0. Okay, so that's what we're looking to prove here. The note in the mark scheme was that we need double way implication signs, because anything that we've done going through our algebra here can be reversed as well. Okay, so 4 marks for that question.